In this problem, we're given that the committee has to consist of representatives. So our committee has to be less than or equal to 8, right? And it also has to be greater than or equal to 5. We also know that we have to have at least 2 juniors. So the number of juniors has to be at least 2. So that means that it has to be greater than or equal to 2. And the same thing is true for seniors. It has to be at least 2. So that means we need more than or equal to 2. This is a nice problem because it tells us what the x and y have to value. X is the number of juniors. And y is the number of seniors. So then we can go on to our inequalities now. So the committee has to be at least 5, but less than 8. So that's 2 separate pieces. So we know that the number of juniors added with the number of seniors has to be more than or equal to 5. We also know that the committee has to add up to something that's less than 8. Less than or equal to 8. So those are 2 inequalities. But then we also have to factor in that the number of juniors has to be greater than or equal to 2. And the same thing can be said for the number of seniors. To graph the first 2 inequalities, I've converted them into y equals form so I can see the associated equations. So you'd see that the blue line has a y-intercept of 5 and a slope of -1. So it would look something like that. The red line has a y-intercept of 8, and it has a slope of -1 as well. So that will look something like this. And the last 2 inequalities would be a vertical line where x has to be greater than 2. And y has to be greater than 2 as well. And then as far as the shading goes, right, you actually wouldn't have shading in this problem because you can't have fractional or decimal people. So it's only going to be some coordinates, right? So coordinates that would work would be at these intersections. Or any whole numbered integer that would work anywhere in this space. Right, so you're going to fill in those values that will possibly work as solutions. And that solves number 37.